Hello, my beautiful computer science students. Welcome to another lesson where I, Goldie, am going to take you through our unit that we are currently on, Unit 7, ArrayList, and we are going to go through Lesson 6, the selection sorting algorithm. Okay, so sorting algorithms, we can sort arrays and array lists, and we want to sort in order to arrange the data in some sort of meaningful way. Now, usually for us in this class, this means numerical order or even alphabetical order as well. But nothing really beyond that we'll see. We're going to be going through how to sort with arrays and array lists both today. There's many different sorting algorithms. We're going to talk about just one today, but they all have their pros and cons depending on what you're trying to do. So we're going to look at the selection sort right now in this lesson, and then in the next lesson we're going to look at the insertion sort. So those are the two we're going to cover in this unit. The other ones that you'll see, merge sort is a recursive sorting algorithm that we are going to talk about in Unit 10 when we talk about recursion. But the other ones we don't talk about but you might see include the bubble, quick, shell, and heap. Right? All of those have, again, pros and cons, but they all have the end result of sorting the array in some way. So the selection sort algorithm, we're going to go over the steps right now, and then we're going to see it used in an example because I think it's just a little better to see a visual of this. But here are the words for those word people. Obviously, I'm not one. But the selection sort algorithm starts off with setting what we call the current position equal to 0. And the current position represents the current index that you are on. So you're going to start with this algorithm at index 0. You're going to look to the right of that current position and find the smallest value, okay, to the right of that. And when I say smallest value, you'll have that current element at that index and you're trying to find the smallest value less than that element, right? So if this is a 10 that you're currently at, you want to try to find the smallest element less than 10, right? If everything to the right is greater than 10, there's not going to be a smallest value. You're trying to find the smallest value that's less than 10, but also the smallest. You're going to swap the current position, the element at the current position, with the smallest value that was found. Okay, so you'll swap them. And then you'll move the current position over 1. So it'll become index 1. And you continue these steps until you reach the end of your array. And by the time you reach the end of your array, you're going to have a sorted array. Okay. Again, it's best if we kind of see a visual of this. So we're going to sort the list 10, 5, 3, and 2. And we're going to see this selection sort work on this smaller list. So we start at 10. So our current position is index 0. So that's going to be our starting position. We're going to find the smallest value to the right. So we're going to compare 10 to 5, 3, and 2. So all of them are smaller than 10, but which one is the smallest? And that's what we're going to find. Okay? 2 is the smallest value to the right of 10. Okay? So we identify it. There it is. And what we're going to do is swap these two. So the 5 and 3 are going to stay in the same spot, but we're going to swap these two elements. So our array looks like this. The 2 goes in that first spot and the 10 goes in that last spot there. And then we move the current position to the right by 1. So index 1 now becomes our current position and we are at element 5. So next we find the smallest value to the right of element 5. Which between 3 and a 10, it's going to be 3 is going to be the smallest element. We're going to swap these two again. Okay. So 3 and 5 get swapped. And then I move the current position to the right to index 2. Looking to the right, there is no element smaller than 5, so a switch will never happen. Okay. I guess I left that out there. So a switch never happens. The algorithm does not actually go to the last index since the array to the left of the current position is always sorted. So you'll notice how once we get here to the second to last element, okay, at index 5, we don't actually go to a current position of 10 because everything's sorted by then. Okay? And that's our selection sort algorithm. Okay? So we saw the situation where we find, let me go back here. So where we would find an element smallest to the right, we swap. If we run into a situation like here where we have a 5 but there's nothing smallest to the right, no swaps are made. Okay? No swaps would be made, and we just move the position over by 1. And in this case, we don't do that because 10 is the last element, and we don't go to the last element for this one. Okay? So we're going to look at the code now. Now, with sorting algorithms, you'll note that there'll actually be nested loops in the algorithm itself, one inside of the other, because you're basically looping through twice, right? Your outer one for the selection sort, your outer loop is going to be moving your current index. Okay? So that current index is going to be controlled by that outer loop. The inner loop is going to be looking at everything to the right of that current index. Okay? Now, because of the complexities of sorting algorithms, you rarely would have to code a sorting algorithm from scratch on the AP exam. Okay? You might have to recognize it and be able to read through it and understand what it does. Actually, you will have to do that. I shouldn't say you might. You will have to do that in the multiple choice section for sure. But I don't want you having to worry about memorizing this code line for line. It's true if you use it enough, you memorize it, but don't focus so much on memorizing it line for line, but focus on, okay, if I read this, I understand what it does. Okay. So here's the selection sort for an array. Let's say I have an array of elements, and I'm not going to show what those are. We're just going to focus on the generic selection sort code. So my array is called elements. Here's my outer loop. I'm going to call it J, and it's going to loop through all of my elements starting at 0, but not the last one. So notice in the loop header here, I have elements.length minus 1 because I'm not going to take my current index to that last value. Okay. My min index, I'm going to call my minimum element the current element that I'm at, right? So that's going to be just equal to J. Now I'm going to have a second loop that is going to loop through everything to the right of my current index. Okay? So when I had, I think this was it, right? I assumed this was my minimum at index 0. So min index would be 0. And then I'm going to have a loop that starts at J plus 1. So that means one more. And I want to loop through all of the values, right? So that's why this goes all the way to the end here, because I do want to go to the end. I want to loop through everything to the right. And what do I want to do? Well, I want to see if that element to the right is less than my current min index. Okay? And if it is, that means I have a new min index. Okay? So again, looking at my example, because I like examples, I think they're nice. This is my current min element. I look 1 to the right. Is 5 less than 10? It is, so that means that this becomes my new min. And then I go through again. I compare 5 to this min. This is lower, so this becomes my new min. I compare 2 to my min. 2 is less than that. So once I reach the end, this index 3, which contains that 2, that's going to be my min index. Okay. Once I have located, so this locates this and this, they locate that minimum value. And once I have that minimum value, then I want to swap. Okay. I want to swap my current element, which is J, with my min index that I found. Okay. And that's the swapping element here. J is my current index, and I have min index, which is what I found. And then I have my 3 lines of code there that are going to be my swapping algorithm. Okay. Yeah, that's my selection sort. Beautiful, beautiful, beautiful. Okay. Now this is for an array. A couple notes about an array list. Array list does have built-in sorting methods, so you don't really code an algorithm for sorting arrays. It works very similarly to this, right? We've talked about before how if we have an algorithm for an array, to switch it to an array list, it's not that hard. Elements.size, right? Elements.size. Elements.getMinIndex, elements.getK, right? So it's not hard to switch this to an array list, but you rarely have to do so because they have built-in methods. Now, we don't cover those built-in methods on the exam, but in case you were curious, there is a class called collections that has all of these algorithms already created for an array list. So let's say we have numbers is an array list. If we wanted to sort numbers, we would have to do collections.sort numbers. And the way it sorts is actually based on a version of merge sort, which again we haven't covered yet, and it's just a little extensive because it's a version of it. But it does sort it. Okay, it is a sorting algorithm. You do have to import the collections class, which is also in the util package, just like ArrayList. So this isn't a built-in method for ArrayList. It's from a separate class, but it works on an ArrayList. Okay, that's not covered on the AP exam at all. That goes a little bit beyond this course, but in case you were interested, ArrayList does have technically built-in sorting methods. So. Last couple questions here. These would be more questions that you'd find on the AP exam, where they would give you, in a multiple choice section, they would give you like the selection sort code, and then they would say, given this array on the screen, what will be the contents of the array after 1 pass or 2 pass or 3 pass of the algorithm. That's usually what they test more, is just do you recognize the algorithm and then do you understand how it's implemented. Okay, so we're going to answer these questions and wrap up our lesson here. So if the element contains the values here, right? If elements, meaning our array, contains these values, you can see it's unsorted. What will the contents of the array be after 1 pass, 2 pass, 3 pass? After 1 pass. So we start at the first element, and we find the smallest element to the right of 67, which would be 24. And then we swap them. So after 1 pass, 24 and 67 were swapped. Everything else stayed in the same position, but 24 and 67 were swapped. Okay? So that's after 1 pass. That's the contents of our array. After 2 passes, well, add the next pass, my current element moves up 1, and I look for the smallest value to the right of 46. What's the smallest value? Well, there is nothing smaller than 46. So that min index never gets changed because there's nothing smaller than the element 46. And if the min index never changes, that means min index and j are the same number. So when I go through that swapping algorithm at the bottom there, that swapping algorithm doesn't really swap anything because it's the same element. So after 2 passes, my array looks the exact same. The exact same. I didn't swap anything because there was nothing smaller to the right of 46. After 3 passes, 72 now becomes my current element. I look to the right. 50 is the smallest element to the right of 72. So I swap those two. And after 3 passes, this is what my array looks like. And technically, it is in order. Okay, so my 4th pass, this would be my current element. This is technically in order, but the computer does not know that. Okay, it'll keep going. It'll keep passing through that sorting algorithm. It's just no more changes will visibly be made. Notice how at any point, everything to the left of your current index is sorted. Okay, everything to the left is sorted. Everything to the right remains unsorted. Okay, so that's the selection sort algorithm. Everything to the left will be sorted. Everything to the right would be unsorted until you reach the end there. Okay. but that's going to be your selection sort algorithm. So thank you guys so much for watching, and I will see you in the next lesson.